4.3.1 Harmonic Motion Warm-Up. Buried Treasure. You seek a treasure that is buried in the side of a mountain. The mountain range has a sinusoidal cross-section. The valley to the left is filled with water to a depth of 50 meters, and the top of the range is 150 meters above water level. You set up an x-axis at water level and a y-axis 200 meters to the right at the deepest part of the water. To the top of the mountain is at x equals 400 meters. So for this, it says we want to write an equation expressing y in terms of x for the points on the surface of the mountain. So the first thing you need to do to write your equations, we need to figure out, what our amplitude or midline are. So to find that, we need our maximum and our minimum heights. So our maximum height we know is at 150 meters, because that's what it told me, and you can even see from the graph right here. And the other one is the lowest is a depth of 50 below water level, so negative 50 is your minimum. So to find the amplitude, we know it's the maximum minus the minimum divided by 2. So in this case, 150 minus negative becomes positive 50 divided by 2. So that would give me an amplitude of 100. And my midline is going to be my maximum plus my minimum divided by 2. So 150 plus negative 50 divided by 2. And when you do that, you're going to end up with 50 for your midline. So your midline would be somewhere in here. So notice that our graph on the y-axis does not start on a key point. It doesn't start on the midline, nor does it start on a max or min. So that means that our equation is going to have a phase shift. So because I don't know the period of the function yet, I'm going to use a cosine graph for my phase shift, and I like to use positive cosine graphs, so I'm going to start at the maximum right here for my graph. So I have y is equal to a times the cosine of b times x minus c plus d is my general equation. We already know our a and our d are amplitude and midline. We need to figure out the b value, but to figure out the b value, I need to figure out the period of my graph. So I know that from a max to min, or min to max in this case, that would be half of a wavelength. So I know the distance from here to here is 400 and here to here is 200. So 400 plus 200 gives me a distance of 600. Now recall that that's not a full wavelength, that's a half a wavelength. So if I want the full wavelength, I would multiply by 2. So the period of our graph is actually equal to 1200. So now that I know that, I can use my equation. We know that the b value, or the frequency, times the period is equal to 2 pi. So if I want my b value, I know it's going to be 2 pi divided by the period. So in this case, 2 pi divided by 1200 is equal to pi over 600. So that is my b value in my equation. So now I can start writing my equation. I have y is equal to my amplitude, which is 100, times the cosine of my b value, which is pi over 600, times, and I need a phase shift, we said, because we're moving to the right, 400. So x minus 400 plus my midline, which is at 50. So this is one possible equation. Of course, I could have started at negative 50 for a minimum, and I would have x plus 50 here, and then this would have a negative in front of the 100 for the amplitude. Or I could figure out my key points. If my period is 1200, you remember you find your key points by taking the period, which is 1200, and divide it into 4 equal parts. So 300 for your key point. So this is 400. That means this key point where it crosses the midline would actually be at 100. And then you could write a sine equation. Y is equal to 100 times the sine of pi over 600 times x minus 100 plus 50. So that would also work. So of course there's many different equations that we can have. So then it says we want to show by calculation that this sinusoidal contains the origin. So I'm going to go ahead and just get rid of this so it's not in my way. So to show this, I'm just going to plug in 100 for x. And then I can use algebra to solve. So 100, and this would be the cosine of, and 0 minus 400 is just negative 400 times this would be negative 400 pi over 600 plus 50. Of course, those zeros would cancel out, so it's really negative 4 over 6, which is negative 2/3. And then if you think about your unit circle, on my unit circle, I know that positive 2/3 would actually be here, but we want negative 2/3, so we starting the x-axis and going clockwise, which would be here. So on my unit circle, I know that if I'm looking for the cosine, that's my x value, and my x value there would be negative 1/2. So the cosine of that is negative 1/2. So 100 times negative half is negative 50, plus 50 is equal to 0. So that means that 0, 0 is on my graph. That's all I want you to do, show by calculation. And this last part's a little bit harder because now we want to figure out, it says the treasure is located within the mountain at 130 and 40. This point's not in the graph, as you can see. So it says which way would be shorter way to dig for the treasure, a horizontal tunnel or a vertical tunnel. So I'm going to go ahead and use my calculator in order to help me solve this. So we're going to go ahead and plug that into our y equals on our calculator. So you can see that I have 100 cosine pi over 600, x minus 400 plus 50. And so on my window, of course, you don't want to use your normal standard scale, so you're going to want to change that window. So I did my x minimum negative 200, maximum 400, and y minimum negative 50, and y maximum 150, because that's what we had on our graph. So if I go ahead and hit graph, this is what your graph is going to look like. And I actually, in my stat plot, turned this on, so that is actually the point right there. If you go to my stat plot, you can see it's 130 and 40, just so you can see where the buried treasure is. So for this, the first thing I'm going to do is go ahead and look at second trace value, and I'm going to look at the x value of 130. So when my x value is 130, you can see that I'm all the way up here. I have a y value of 65.64. So I want to figure out what that vertical distance is so that I know if I want to dig vertically or horizontally. So of course I'm going to take that 65.64 and subtract it from that actual point of the buried treasure. So when we did the actual subtraction, we get the vertical dig to be 65.64 minus the 40, which gives us 25.64 meters. So that distance from here to here that we would be digging would be 25.64. So we need to do the same thing for when our y is equal to 40. We want to figure out what would our x be and what would be the horizontal dig. So I'm going to go back to my calculator for that. And in my calculator, now I'm going to go to my y equals, and I'm going to plug into my y equals 40 and hit graph. So now we are looking for what is the distance horizontally from our equation to the buried treasure, and how far would that distance be? So would it make more sense to dig vertically or horizontally? So that means I need to find the intersection between that line and our actual graph. So if I go to second trace, I'm looking at number 5, which is the intersection. And of course, you just get close to the intersection, hit enter 3 times, 2, 3. And you can see that the x value that we get from our graph would be 80.87. So if I go back to here, we get 80.87. So that means if I'm looking horizontally, remember it was normally, the treasure's at 130, so the horizontal dig is going to be 130 minus 80.87. And so when we do that, we get a horizontal dig of 49.13. So 49.13 meters would be the horizontal. So of course that means that the vertical dig is shorter at 25 meters. And so again, if you look at your calculator, that means that this distance from here to here is shorter than this distance from here to here. So that means that, oops, we would want to do the vertical dig. So my answer for this, it says which would be the shorter dig, horizontal and vertical. So the vertical dig is shorter. That's 25.64 meters. So if I'm looking for my buried treasure in the mountain, we're going to do the vertical dig.